If your RAG system is returning wrong or irrelevant answers, the problem is almost always chunking, not the embedding model, not the language model. Chunking. How you split your documents before storing them determines everything about what your retrieval system can and cannot find. In this episode, we go through every major strategy, line by line. Remember from episode 1 that an embedding compresses meaning into a single vector. If you embed an entire 50-page document as one vector, that vector becomes an average of everything in the document. Specific details get buried. A query about something on page 3 will score weakly against a vector that represents all 50 pages equally. The solution is to split your document into small focused chunks before embedding, so each vector represents one clear idea. Loading a PDF with LangChain takes 3 lines. We import the PyPDF loader, point it at our file, and call load. It returns a list of document objects, one per page. Each document has 2 things, the page content as a plain text string and a metadata dictionary containing the source file name and the page number. That metadata will follow the chunk all the way into Chroma, which means we can filter by page number at search time later. The simplest approach is fixed size chunking. We set a chunk size of 500 characters and split every document into equal-sized pieces. This is fast and predictable. The problem is that it is completely unaware of sentence boundaries. A chunk might start in the middle of a sentence or cut a key idea in half. The retrieved chunk will confuse the language model because it is missing context. This is why fixed-size chunking alone is rarely used in production. Chunk overlap solves the boundary problem. When we set an overlap of 100 characters, each chunk starts 100 characters before the previous one ended. This means any idea that spans the boundary between 2 chunks will appear in at least one of them in full. Without overlap, a key sentence cut across 2 chunks will be incomplete in both. A small overlap of 50 to 200 characters is almost always worth the extra storage cost. The recursive character text splitter is the gold standard for most RAG applications. It tries to split on paragraph breaks first. If the chunk is still too large, it tries new lines, then sentences, then spaces, then individual characters as a last resort. This means chunks almost always end at natural language boundaries. You get clean, readable pieces of text that make sense on their own. Use this one as your default unless you have a specific reason not to. Now we load our chunks into Chroma. We create an OpenAI embeddings object pointing at the same model we used in episode 1. Then we call Chroma from documents, passing our chunks, the embedding model, and a directory path to persist the data on disk. LangChain automatically embeds every chunk and adds it to the vector store. We do not need to write a single loop. One call handles everything. Querying is just as clean. We call similarity search on our vector store, passing the query text and the number of results we want. LangChain embeds the query automatically and returns the top matching document chunks. Each result includes the original text and the metadata, so we know exactly which page of which file the answer came from. This is already a complete end-to-end retrieval system. A few production tips before we wrap up. A chunk size between 300 and 600 characters works well for most documents. Set your overlap to about 10 to 20% of your chunk size. Always carry metadata through to Chroma so you can trace where each answer came from. And remember, smaller chunks give you more precise retrieval but less surrounding context. Larger chunks give more context but weaker precision. Test both and measure before deciding. You now know why chunking matters, how fixed size and recursive splitting differ, how overlap preserves context across boundaries, and how to load real documents into Chroma with LangChain. In the next episode, we put it all together and build the full RAG pipeline from a user question to a grounded answer. If this series is helping you, please subscribe. See you in the next one.